Hi there and welcome to tutorial 16, which is the 7th video on trigonometry for the Core 3 Edexcel Maths A-Level course. As always, we take a look at the scheme of work just to see what we're going to do. We've done everything in green so far, and now we're moving on to this section here. We want to be able to know about the double angle formulae and the use of the formulae sine A plus B, cos A plus B, and tan A plus B, and that's where we're going to start today. We're going to do the rest of it in further videos. So we're going to just work on, at the moment, formulas for sine A plus or minus B, cos A plus or minus B, and tan A plus or minus B. We call these, we're going to call these the addition formulae, and we're going to learn about these today. Okay, right, to start with, the addition formulae. If you were to guess, what do you think an expression for sine of one angle A plus another angle B was? What would you guess? Now you might guess it would be sine A plus sine B. Okay? And you would hope that would be the case because it would make life easy. In fact, that isn't the case, and we could show that doesn't work by finding a counterexample. Just take a second to think of, can you think of an angle A and an angle B that you could choose to show that sine A plus B was not equal to sine A plus sine B? Well, what you could do something like sine of, let's say, 30 plus 60. Okay, and by the way, that's sine 90, and you know sine 90 is 0, so you know this is 0, but sine 30 plus sine 60, if it were equal to sine 30 plus sine 60, well, you would have a half plus root 3 over 2. And that certainly is not equal to 0, so you know this doesn't work. Now I'm going to show you what the formula for sine A plus B is. I'm not going to derive it for you. It is in the book if you want to look, but I'm just going to show you what it is. And it turns out, and this is given to you in your formula booklet in the exam, that sine A plus B is equal to sine A cos B plus cos A sine B. And cos A plus B is cos A cos B minus sine A sine B. These are given in the exam to you. Now, you might need to know what sine of A subtract B is. You'd like a formula for that as well. And you could think of that, you could get this from using the above formula. You could think of that as sine of A plus minus B. Okay, you could plus negative B. You could think of it like that. And you could use the double angle formula above that we know because we've converted this to an addition. Well, that would just be equal to sine A cos negative B plus cos A sine of negative B. Okay, now you know that cos is an even function. If you think of the graph of cos, quick graph of cos up here, it has the same value for a negative angle as it does for a positive angle. So therefore cos negative B is the same as cos B. So this would be sine A cos B. And you know that sine is an odd function. Remember the sine graph looks something like this. And the sine of a negative angle, okay, is the same value as the sine of a positive angle, but it's just the negative. Okay, they're opposite signs. So this here, sine of negative B, must therefore be equal to negative sine B, in which case this would end up being minus cos A sine B. And hence we have a formula for sine A minus B as follows. Now, I'd encourage you to have a go at cos A minus B yourself. Maybe pause the video, have a go at that yourself in the same way I've done above. But with a bit of luck, if you do that, you would get cos A cos B plus sine A sine B. Okay, and that would be the formula for this one. Now, you need to be aware of this formula, this formula, and this formula. Don't worry about writing it down just yet. I will show you a slide where they're all on together. Now, you might like to also have an addition formula for the tan function. You might want to know what tan A plus B is in terms of tan A and tan B. And I'm going to show you how that comes about. You probably don't need to know how to do this in the exam, but it's good for your algebra and good for your background knowledge. Tan A plus B, by our definition of tan, must be equal to sine A plus B divided by cos A plus B. Okay, all we've done is use the definition of tan there. Now we have double angle formulae for sine A plus B. We did that on the previous slide. We knew that was equal to sine A cos B plus cos A sine B. Okay, and we knew a formula for cos A plus B, and it was cos A cos B subtract sine A sine B. Okay, so all we've done here is stated the definition of the tan function and said it was sine over cos. Then we've used the double angle formula, the addition formula for sine and cos. When it comes to the tricky part, this just requires a little bit of vision. What you want to do is you would like, if you did the following, if you divided everything you saw, okay, by cos A cos B. If you divided top and bottom of this fraction by cos A cos B, you're not changing the fraction because you're doing the same to the top and bottom. Let's see what you get. Well, sine A cos B divided by cos A cos B would just give you tan A. It would end up just giving you sine A over cos A, and the cos B divided by cos B is 1. Doing the same to this part here, you would just get tan B. Cos A cos B divided by cos A cos B would just be 1, and sine A sine B divided by cos A cos B would give you tan of A multiplied by tan of B. And I therefore have a double angle formula for tan A plus B. So all I did was write it as sine over cos, expand using the addition formulae, and then divide everything by cos A cos B, every term by cos A cos B. I get myself a double angle formula. Now I would want to know what tan A minus B is as well, and I'll leave that up to you to check what that is, but I'll show you on the next slide what that turns out to be. And here are, in summary, the the addition formulae you need to know. And these are given to you in your formula booklet for the exam. The plus and minus here, it summarizes it all in one. If you want sine A plus B, you take sine A cos B plus cos A sine B. If you want cos A plus B here, it would be cos A cos B minus sine A sine B. And if you want, say, tan A minus B here, it would be tan A minus tan B over 1 minus tan A times tan B. Okay, so those formulas are given to you in the formula booklet. Okay, let's go ahead and try and use them. Here's an example. It says, without using your calculator, use the addition formulae to find the exact value of sine 15. So I want to find sine 15 exactly without using my calculator. I could write it, I'm going to end up using one of these here. I could write that as, let's say, sine 60 take away 45. The reason I'm doing that is I know sine 60 and sine 45 and cos 60 cos 45 exactly because I've learnt those particular angles, what the answer for the cos and sine of those angles are, and that would give me sine 15. Now expanding this using the addition formula up here, it would be equal to sine 60 cos 45 subtract cos 60 sine 45. And I know the values of each of these things here. I know sine 60 is root 3 over 2. I know cos 45 is root 2 over 2. I know cos 60 is a half, and I know that sine 45 is root 2 over 2. Okay, so I've just substituted those in there. And what am I going to get myself? Well, I'm going to get myself root 6 over 4. Okay, and then I'm going to subtract root 2 over 4. Which, if I do that, is simply root 6 subtract root 2, all divided by 4. And I have found myself sine 45 exactly without using a calculator whatsoever. Okay, why don't you try one yourself? Exactly, very similar to this. Off you go. Try and find the exact value of cos 75 using the addition formulae. Okay, I'll just quickly show you this one. I'm not going to go into it too much, but cos 75, you could say that is equal to cos 30 plus 45, let's say, and you could expand using the addition formulae and say that's equal to cos 30, cos 45, subtract sine 30, sine 45, and you know cos 30 is root 3 over 2, you know that's root 2 over 2, so that's root 3 over 2 times root 2 over 2, subtract a half times root 2 over 2, just subbing in here, and you could say that is root 6 minus root 2 all over 4, in a similar way to what I did previously. Right, let's do a different type of question. Okay, here's another type of example of question that's quite common. It tells us that sine A is negative 3/5 and A is a reflex angle, and it tells us that cos A is negative 12/13 and B is an obtuse angle. It asks us to find the value of cos A subtract B. So we're going to use our double angle formulae, and we're going to use one of these ones here. Let's just write it out to start with. We know that cos A subtract B using our double angle formulae is going to be equal to cos A cos B, and we're subtracting, so it's going to be plus here sine A sine B. Okay? Right. Now, we are told sine A. We've got this here. We are told cos B. We've got this here. What we don't know is we don't know the value of cos A and we don't know the value of sine B. So we need to find them, and before we can substitute all the values in and work out an answer for cos A subtract B. Now, how are we going to find cos A? I'm going to do a bit of side working down here. I'm going to just do it off at the side here. How are we going to find cos A? Well, you can use the identity that cos squared A is 1 minus sine squared A. Okay, and that would be 1 subtract negative 3/5 squared, and you type that on your calculator and you would get 16 over 25. So you know cos squared A is 16 over 25, so cos A, taking square roots of both sides, is plus or minus 16 over 25. Now the question is, which one is it? Is it the positive, taking square roots of both those, it would be 4 over 5. So it would be 4 over 5. Now the question is, which one is it? Is it positive 4/5 or negative 4/5? Well, we're told in this case that A is a reflex angle. So let's look at the cos graph. The cos graph comes down here, crosses at 90, then is negative all the way between 90 and 270, and then is positive after 270. So we know the region we're talking about is this region here. Now we know that cos is negative there, so we're going to take the negative value. So we're going to take the negative value here, and we're going to say that cos A is negative 4/5. And we found our cos A. Right? Let's do the exact same to find sine B. Right, I'm going to use a different colour pen. We could say that sine squared B is 1 minus cos squared B. and that would be equal to 1, subtract, and now cos squared b is 12 over 13, so it would be negative 12 over 13 squared, and that's 144 over 69. So we would, if you type that in your calculator and work it out, you should get 25 over 169, and that's sine squared b. Now the question is, what's sine b? Well, it's the square root of this, so it's plus or minus 5 over 13. Question again is, which is it? Positive 5 over 13 or the negative 5 over 13? Let's draw a quick graph. We're considering b here to be obtuse, so it's bigger than 90. Now the sine graph looks as follows. Now, bigger than 90, between 90 and 180 even, there's our obtuse angle. Sine's positive, so we know we want the positive angle here and we don't care about the negative. So we found cos A, we found sine B, we were given sine A, we were given cos B, we can plug it in and now work it out. So let's have a go. Cos A, well, cos A is negative 4/5 times cos B, which we have is negative 12/13. And we're going to add sine A, which we're given, is negative 3/5. And we're going to multiply that by sine B, which is positive 5 over 13. Okay, if we do that in our calculator, we get 48 over 65, subtract 15 over 65. And with a bit of luck then, we do that correctly, we get 33 over 65, and we have found ourselves our cos A subtract B. And we're done. So that's another very typical type of question that can come up. And you use your addition formulae, you use your cos squared plus sine squared is 1 identities, and everything comes out nicely. Right, I'd encourage you to have a go at the following. Very similar example yourself. I'll show you the answers in 10 seconds. And the exact answer for sine of A plus B is as follows. It should have been 3 plus 4 root 3 all over 10. I'm not going to go through that. It's very similar to the last example. Just make sure you can get that answer. Okay, moving on to a different type of question that can come up. We can use the addition formulae to solve equations. Here's an equation. We want to find theta between 0 and 360, and we're solving 3 cos theta is 2 sine theta plus 60. So just follow your nose and expand out the sine theta plus 60 using the addition formulae, using that one up here. So we'd say that's equal to 2, and we'd say that is sine theta cos 60 plus cos theta sine 60. Okay, and expanding that out a little bit further, we would therefore say that 3 cos theta is equal to 2, and we'd have cos 60 is a half, so we'd have sine theta times a half, which is just a half sine theta. And here we'd have cos theta times sine 60, and sine 60 is root 3 over 2, so we'd have root 3 over 2 cos theta. So 3 cos theta is therefore multiplied 2 inside to the brackets, we would have sine theta plus root 3 cos theta. Now the question arises, how could we solve from here? Well, you should be familiar with these type of ones from Core 2. If we divided everything by tan theta, if I divided everything by cos theta even, I'm thinking ahead of myself, if I divided everything by cos theta, I would get 3 cos theta over cos theta is 3, sine theta over cos theta is tan theta, and root 3 cos theta divided by cos theta is simply root 3. And we get an equation, a simple equation with tans in it. Now I'm going to rearrange this. I'm going to subtract root 3 off both sides, so tan theta is 3 subtract root 3. Okay, and therefore I can work out my principal value of theta. So I'm just going to swap these around. I'm going to say theta is therefore the inverse tan or arctan of 3 subtract root 3. Okay, so making sure your calculator is in degrees mode and you work out the inverse tan of 3 subtract root 3 and you should get yourself 51.7 degrees. So theta is equal to 51.7 degrees to 1 decimal place. Okay, as always, draw your tan graph. Quick tan graph here just to see where the other solutions, if any, are. Remember, tan graph looks something like this. That would be 90. Comes up here to 180. That would be 180. 270. Okay, and it ends up finishing off here at 360. Okay, so what other angle would give you the same value for tan as 51.7? Well, 51.7 is somewhere here, 52-ish, and it would be this one here. It'd be 180 plus that. So the other angle would be 51.7 plus 180, which would be 231.7 degrees. And obviously, what you could do is you could substitute that theta value in and that theta value in to the original equation and check it works to make sure you've done the question right. But that's how you solve those type of questions. Okay, so now I'd encourage you to try and solve one yourself, very similar to this. In 10 seconds I'll show you the answers. And if you had expanded out using the double angle formulae and tried to solve, you should have got that theta was 150 degrees and 330 degrees. Okay, the last type of question that can come up, some sort of use of algebraic expressions. We are told that 2 sine of x plus y is equal to 3 cos of x minus y. And we are told to express tan y, so we want to find an expression for tan y in terms of tan x in terms of tan y. So we're not asked to solve this, we're asked to find what tan x is in terms of tan y. Okay, let's do this by using the double angle formulae or the addition formulae. Let's use that one for this side. So we'd have 2, and this would end up being sine x cos y plus cos x sine y on the left hand side, and on the right hand side we're told that this thing is equal to 3 and cos x minus y, so it would be cos x cos y, and we're doing a subtract here, so we get a plus on this side, plus sine x sine y. Okay, let's expand out. That would give me 2 sine x cos y plus 2 cos x sine y is equal to 3 cos x cos y plus 3 sine x sine y. Okay, now what could I do? Now I want tan x going on here, and I also want tan y going on. So for example, if I wanted to tan x out of this, okay, I could divide by cos x and cos y, and the same thing would work along all of these. If I decided to divide everything by cos x cos y, let's see what you get. This would turn into 2 tan x. This would turn into 2 tan y. This here would just turn into 3, and this here would turn into 3 tan x tan y. Okay? Now we want everything to do with tan x on one side of the equation, so I'm going to subtract 3 tan x tan y from both sides and subtract 2 tan y from both sides. So this here is going to end up over here, and this here is going to end up over here. So I'd have 2 tan x subtract 3 tan x tan y is going to be equal to 3 subtract 2 tan y. Okay, now we want to factorise out a tan x out of this. So tan x, 2 minus 3 tan y is going to be equal to 3 minus 2 tan y. And last stage, dividing both sides by 2 minus 3 tan y, I would have tan x is equal to 3 minus 2 tan y over 2 minus 3 tan y. And I'm done. Now that's quite tricky here, but this line is probably your hardest line to decide to divide everything by cos x, cos y. Okay, just to finish with, have a go at a similar one yourself. Here we go. Right, all you had to do was follow your instincts here, expand these out using the addition formulae. So that would have been 3 sine x cos y minus 3 cos x sine y for this. And this would have been subtract sine x plus y, which is simply sine x cos y plus cos x sine y. And you are told this is equal to 0. Okay, now we just do the subtraction. This is 3 sine x cos y minus sine x cos y, so we have 2 sine x cos y. And here we have negative 3 cos x sine y, and subtract another cos x sine y, so we'd have subtract 4 cos x sine y equals 0. And what we could do is divide everything by 2, so we'd have sine x cos y subtract 2 cos x sine y equals 0. And we want a tan x going on and we want a tan y going on, so with a bit of foresight, if we said to ourselves if we divided everything by cos x cos y, that would help us. So let's do that. If we divided everything by cos x cos y, I'd get a tan x here, and over here I would get myself minus 2 tan y equals 0. And then if we add 2 tan y's to both sides, I get what I was looking for. Tan x is equal to 2 tan y, and I'm done. Okay, and that's all the type of questions that come up with the addition trigonometric formulae. Okay, so just to consolidate all this, I'd say read chapter 7, page 106 to 113 in the book, and do everything on exercise 7a. There's a variety of different type of style questions that come up. You should do all of those. Thank you very much for watching this video.